Assalamu alaikum students. A very good evening to everyone. Am I audible to you all? Are you able to see the slides? I hope my voice is clear. Can anyone please confirm? Are you able to see the slides? Yeah, thank you. So first of all, um, this week, I hope you all aware that today is the due date for your discussion board 2 activity. And let me check. Still how many? Oh my God. Yeah, still I can see that there are 7 students not yet started. So if any one of you not yet started, please make sure that you complete the activity on or before the due date. Okay. Um, Yes, coming to this week activity, you have one assignment 2 that will be available from early morning tomorrow. I mean, after tonight, it will be available to you all. And the link in the assignment 2 is updated. So it is working. The new link is working. And if anyone has faced difficulty, please write an email immediately to me. Not today, tomorrow. Uh, because tomorrow only it will be accessible for you all. So please make sure that it is available to you all from tomorrow. If you are not able to access, please let me know through email. And some students, they already written some emails. So I am replying by going through your comments and um, all these things. So soon you will get reply for your emails also. So that is one thing from my side as an announcement. And this week we need to cover 3 modules, module 10, 11, and 12. I will try my best to cover the content in both the sessions. If anything is left over, that will be given as a recording because what I heard is next week is your last week for this semester, if I'm not wrong. So today is, yeah, second, and I think your final exams will start from 16th or 13th. I don't know exactly the dates, but hopefully the exams will be from 16th of August. So this week and next week only you have classes. So we need to cover the content this week and by next week itself. So you have only one assessment activity that is due this week. That is assignment 2. Yes, yes, yes. Uh, the link is updated. So the new link will be posted to you all around 12 a.m. or 1 a.m. It will be available to you all so that you can get access. And if still the problem exists, please let me know. But from my side, I have double checked. The link is updated. It is working. Let me check again whether they updated. Okay. Assignment 2. Yes, they updated the link and it is working. So no issues. Okay. So you all will get access around uh, tonight, 1 a.m. or something like that. So sure, it will work. Don't worry about that. And this is the last activity that you have in this course. Okay, coming to today's class, we're going to start with the operating system security. This is the module 10. So we will learn about the operating system security, which is one of the most fundamental concepts in the computer security. See, as we all know, an operating system is the bridge between the computer hardware and the applications that we use in our day-to-day life. Since almost every program, or you can say the application that you install on your laptop or uh, a mobile or even a desktop, whatever the device it is, it depends on the operating system, and protecting it is essential. So if the operating system is compromised, all the applications running on it may also become vulnerable. Like for example, I just think the computer system as like a multi-stored building, like it's a apartment building. So each floor in that apartment building is depending on the strength of the ground floor, or you can say it as a basement. So if the foundation in the ground floor is not good, that means the entire building is at some risk. Similarly, in the computer systems, every software is a layer which depends on the security of the operating system layers. So a secure system is built from the bottom to the up. The weakness in lower layers will affect every layer above them. So that is why operating system security is a process of protecting the operating system, and it is different, and its different layers from unauthorized access, attacks, and also misuse. So in overall, I can clearly say that the operating system security will ensure that every layer of a computer system works safely and securely, works safely and securely. See, we all know that a computer system is not a single piece of software. Instead, it consists of multiple layers where each layer is going to perform a specific function, and it depends on the layer below that. So if the foundation becomes weak, the upper floors are no longer safe. Similarly, the security begins at the lowest layer and it will extend to the upper layers. See, here the thing is, layers wise, if you see, the bottom is the physical hardware layer where we will have the CPU, memory, storage device, all these things. So physical protection, secure boot encryption, these things are very important here. And then the operating system, that is the kernel. So this is the core system software which is managing the hardware, and the kernel security, updates, and access controls are going to be the focus areas of the security in this level. And then after that we have the user application and utilities, and below that also we have APIs and services and all. So here we will make sure the interfaces and background services are handled properly, the programs are used by the end user in an effective way. So for this we need to focus the security concepts of securing configuration, authentication, updates, and also providing a secure coding, update, least privilege, all these things. So that is what a computer system will follow, a layered architecture where each layer is depending on the layer that is below that. So the physical hardware is going to create the foundation, followed by the operating system and its privileged kernel. Then we have the API and system services along with the user application and utilities. So if a lower layer is compromised, the layer above the become will vulnerable as well. Therefore, the effective operating system security always require protecting every layer starting from the hardware and extending upwards to the applications and all. Like for example, let us say in our university there is a laboratory. Um, we need to secure its systems, various systems that are available in that laboratory, by locking the server room. So installing the latest Windows security update, enabling the secure boot, and ensuring that student applications run with standard user privileges instead of administrator rights, And this layered approach will protect both the hardware and the software from the unauthorized access and all. And then OS hardening measures. See, the hardening means reducing the chances of an attacker successfully compromising a system by removing the weaknesses, applying the security updates, restricting the unnecessary access, and following the security best practices. See, the only objective of this mechanism is the process of securing an operating system by reducing vulnerabilities will remove the unnecessary features and it will apply the security in a best practice. So the OS hardening means making the operating system stronger and more resistant to the cyber attack. So modern operating systems contain thousands of files, services, applications, and even the settings. If left in their default configuration, the attacker may exploit the software vulnerabilities, weak password, unnecessary services, misconfigured permissions, outdated applications. So hardening the process will minimize these risks before the attackers can exploit them. Before the attackers can exploit them. So please remember, the cybersecurity experts they consistently emphasize that most successful attacks exploit basic security weaknesses rather than the advanced hacking techniques. So the organizations that implement the application whitelisting, timely patch management, least privilege access, and defense in depth significantly will reduce their exposure to the cyber threat. And these practices are widely recommended by leading cybersecurity agencies all over the world because they have been proven effective in real world environments and all. And then in continuation to that, see, when a new operating system is installed on your machine, it is usually not fully updated. It may still contain the known software vulnerabilities, missing of security patches, default configurations, and default user account. So if the computer is connected to a network immediately after the installation of operating system, the attacker may exploit these weaknesses before the updates are installed. So this period is often called the window of vulnerability. See, a very important thing here is whenever there is a computer system which can be vulnerable during the installation process before the latest security patches are applied. So therefore, building and deploying a system should be carefully planned process. So the organization should begin by assessing the risk, then secure the operating system before installing the application, protect the critical data, implement the appropriate network security mechanism, and continuously maintain the security through the updates, monitoring, and the regular reviews. So, security is not a one time event, it is an ongoing process throughout the system's life cycle. See, system security planning. So, which means the process of identifying the security requirements, risk, resources, and the procedures before deploying a new computer system. So the system security planning, which means preparing a complete security plan before installing and using a new system. See, the thing is that a security assessment is a detailed evaluation of the organization's current security posture. It helps to identify what are the existing vulnerabilities, what is the possibility of cyber threats, what are the valuable assets, what type of weak security controls or their compliance requirement. So the assessment will allow the organization to understand what needs protection and how to protect it. How to protect it. So the thing is that, see, the system security planning is going to be the first and most important step in deploying a secure computer system. So that means it begins with a comprehensive security assessment of the organization, followed by identifying the right personnel and providing the appropriate training. So the planning process will define the security requirements for the operating system, applications, data, and the users. So that means it will ensure that every component is adequately protected. The ultimate goal is to maximize the security while minimizing the cost. That means it will enable the organizations to deploy the system that are both secure and cost effective, secure and cost effective. See, then we have the process. So the system security planning process is a structured process of identifying all the security related information needs before installing, before configuring, and before managing a complete set of computer system. So it is a checklist that helps the organizations to plan every important aspect of the system security before the deployment. So here, if you see, we will start with identifying the process, and then we will go for the identifying of information, and then we will identify the applications. After that, we will define the users and privileges. After that, we will plan for the authentication mechanism. Then we will assign the administrators. After that, we will plan for the external access. Then we will handle finally before deploying the secure system. So in overall, if you see, the system security planning process is a structured approach where we will be preparing a secure information system before the deployment. So it is going to start by defining the purpose of the system, identifying the type of information that is stored, and determining the application services that will be provided. So the process, which also identifies the user categories and privileges, where we can select appropriate authentication methods and we can assign the system administrators. So together, all these things will be like planning of activities that will help the organization to build a very secure, manageable, and cost-effective system. Cost-effective system. See, the system security planning process will transform the security from a reactive active into proactive strategy by carefully defining the system purpose, by protecting its data, controlling the user access, then securing the administration and implementing multiple layers of defense before the system is over ever deployed. So then see, the operating system, as I said, it is the foundation of every computer system, right? If the operating system is insecure, every application running on it becomes vulnerable. Therefore, see, the process of configuring and securing an operating system is mainly to reduce the vulnerabilities and to improve the resistance of cyber attacks. So that means the OS operating system hardening, which means making the operating system more secure as possible as before we start using it. See, in that way, the cybersecurity professionals, we need to recognize that most successful attacks will exploit the system that have not been properly hardened rather than the system protected by advanced technologies. So, effective operating system hardening will combine the timely patch management, secure configuration process, then removal of unnecessary components, the least privilege access controls, and then providing layered security controls, and then the continuous security testing. So with all these practices we can establish a strong foundation for protecting the applications data and the organizational resources and all. Then the initial setup and patching. See, the way a system is installed is just as important as how it is going to be used. So if the security is ignored, if the security is ignored during the installation process, the attackers may compromise the system before it is fully configured and updated. So the process of securely installing and configuring a new operating system before it is placed into the normal use, we call it as the initial step. Whereas the initial setup, sorry, then patching, which is like the process of installing the updates, software updates that are going to fix the security vulnerabilities, bugs, and some performance issues. So initial setup prepare the operating system for secure use, while patching is going to keep it protected against newly discovered security threats and all. So in this process, as I said, the initial setup and the patching process will establish a secure foundation for a new operating system. So the security begins with a trusted installation, followed by deployment on protected network, completion of all hardware like hardening activities, and the installation of only the minimum required software. So the boot process must be secured because see the device drivers should be validated, and the operating system should always be kept up to date with critical security patches. So before the patches are installed on production system, they should be tested on separate systems to ensure the compatibility and the stability. So together, these steps will reduce the vulnerabilities and improve the overall security and the reliability of the operating system. After that, we have to remove the unnecessary applications and protocols. See, one of the easiest way to improve the security is to reduce the amount of software that is running on a system. Every installed application on your PC or your laptop, so the services or the network protocols can potentially introduce some vulnerabilities. If a component is not needed, it should not be installed. See, unnecessary applications means the programs that installed on a computer that are not required for the system's intended purpose, that we call it as unnecessary application. When I say unnecessary protocol, which means the network communication protocol that are enabled but not needed for normal system operations. So if the system does not need a program or communication protocol, it should be removed or disabled. It should be removed or disabled. So in order to do that, I mean, removing unnecessary applications and protocols, which is one of the simplest and most effective operating system hardening techniques. So installing fewer software packages will reduce the attack surface, and it will make the system less vulnerable to the cyber attacks. So during the system planning, the organization should identify only the software and protocols that required for the system's intended purpose. So the administrators should avoid the default installations which prioritize the convenience over the security, and uh, instead perform the custom installations that include only the essential components. So the additional software should be installed only when a genuine business need is existing. Otherwise, we need not to install that. And then the next topic is configuring the user's role and the privileges. See, one of the biggest security risk in any organization is giving the users more permissions than the actually what they needed. So not every employee should be able to access every file or change every system setting. Like for example, let us take our university. We have like students, faculty, administrators, then some higher officials and all. So each one, they are going to work on the same access system, right? Like su.edu.sa or else eservices dot something like that. But they do not have the same level of access. As a faculty, the role will be different, access will be different. As a student, the role and access will be different. So what will happen now? Similarly, the computer system also will provide different access rights to the different users. So we have users, that means the individual or the accounts that access the system. Privileges, which means the permissions which determine what actions the user can perform. The user categories, which means the different groups such as like administrators, employees, students, or the guests with the different access grants. And then the least privilege, which means the user receive only the permissions required to perform a particular job or task. Then accessible information, which means different user access different types of organizational data. So with all this, configuring the users and privileges is a critical part of operating system hardening. So different users should have different level of access based on their role and responsibility. So elevated privileges should be granted only to the authorized users and only when the necessary it is. So following the principles of least privilege, these things can be done. So the organizations should carefully define the user categories, determine what information each group can access, secure the default accounts, disable the unused accounts, and enforce the strong authentication policies like complex passwords and multi-factor authentication. So these measures will help to protect sensitive information and reduce the risk of unauthorized access. The risk of unauthorized access. Then configuring the resource controls and also installing of additional security controls. See, once the users have been created and their permissions are assigned, now the operating system must control how the system resources are used and provide additional layers of security. So these extra security mechanisms will help to detect, to prevent, and to respond to the cyber attacks. That means the resource controls will determine who can use the system resources and how much they can use it, how much they can use it. See, the thing is that here, after when we define the users and groups, the system administrators should configure the appropriate permissions for the files, for the applications, and even for other resources so that the user access only what they are authorized to use. So that is why the security hardening concept will guide to provide the recommended improvement over the default operating system configurations. So additional security tools, which includes like adding the antivirus software, host-based firewalls, intrusion detection systems, or intrusion prevention systems, and the application whitelisting, which will add multiple layers of protection. So together, these controls will implement the defense in depth significantly. So this will improve the security and the resilience of the operating system, Then system testing. See, for example, let us say you're buying a new car. So before it is delivered to you, the manufacturer, they test the car, I mean the various parts of the car like brakes, engine, lights, and safety features. For what purpose? To ensure everything works correctly. So similarly, after doing the hardening process of an operating system, we must test the system to verify that all security configurations have been implemented correctly. So the system security testing, which is the final step in initially securing an operating system. So its purpose is to verify that all the previous hardening activities like applying the patches, configuring the permissions, enabling the security controls, and removing the unnecessary services. So this have been implemented correctly or not, we need to make sure. So the security checklist will provide in hardening that will guide to help the administrators and to verify the secure configurations. So while automated security review programs and vulnerability scanners will identify the known vulnerabilities and poor configuration practices. So by correcting any issue discovered during this testing before the deployment, now the organization and the administrators, they can significantly improve the security and reliability of the system. After that, we have the application configuration mechanism. See, most of the user interact with the application like a web browser, email system, databases, or any information management systems, or any applications like this. So therefore these applications must also be securely configured. So application configuration, which is the process of securely setting up an application after installation by modifying its settings, storage locations, accounts, permissions, and the security options. See, the application configuration, which means customizing an application so that it operates securely instead of relying on its default settings. So the thing is, the application configuration is a very critical part of system security. So after installing an application, the administrators should create a secure storage location, modifying default configurations, and also, importantly, they need to remove unnecessary default data, scripts, and user accounts. So the special attention must be given to remotely accessible services like web servers, file and file transfer services, because they are common targets for the attackers. So finally, whenever possible, the important application files should be configured as read only. That will allow the server to display them without permitting unauthorized modifications. See, these practices significantly strengthen the application security, and it can reduce the overall attack surface. Then we have a very important concept, that is encryption technology. See, even if an attacker steal your data, the encryption will ensure that the data cannot be understood without the correct key. So the encryption is the process of converting the readable information, that means the plain text, into an unreadable form, that is the chipper text, which will be using a cryptographic algorithm and the key. So only someone with the correct cryptographic key can convert the chipper text back into the original readable information. See here, the encryption technology is going to be a fundamental security mechanism that protect the information both while it is being transmitted and while it is stored. Effective encryption will depends on securely generating the configuring, signing, and protecting the cryptographic key. So secure network service like TLS and IPsec will require public and private key pair, while the SSH, which is going to rely on the server and client key for secure remote administration. So in addition to this, the cryptography file system will protect stored data by automatically encrypting the file, ensuring that only the authorized user with the correct key can access the sensitive information. See, when we do this process together, the technologies which are used and encrypted file system, then it is going to provide a powerful foundation for protecting the data both in the transit and even at the rest stage. Then the security maintenance. See, so far we have seen the concepts like planning of system security, hardening the operating system, then how to configure the applications, how to apply the security patches, and how to use the encryption technologies, all these things. See, cybersecurity is not a one time activity. Remember that. It is like an ongoing process, because every day new vulnerabilities, new malware, and new cyber threats are appearing. So, therefore, every organization must continuously monitor, continuously maintain, and they have to improve their security. They have to improve their security. Like earlier we bought the car, right? So buying a new car is only the beginning. To keep it running safely, you must regularly change the engine oil or change the brakes, or you need to replace the tires, and you need to service the engine as per the schedule. So similarly, the computer systems require continuous security maintenance to remain secure. So the security maintenance means keeping a system secure every day, not just when it is first installed. See, for that mainly, we need to keep the computer system secure throughout the operational life. It includes like monitoring and analyzing the system log to detect suspicious activities, then perform the regular backups to protect against the data loss, recovering from security compromises by using prepared recovery procedures, then regularly testing the system security through vulnerability assessments, and we need to audit and maintain the software by installing the patches, updating the applications, and revising the security configurations whenever it is necessary. So the continuous maintenance will ensure that the system remain protected against the evolving of cyber threats and all the evolving of cyber threats and all. Then maintaining the log. See, imagine there is a security guard who is protecting your home. If something unusual happens at some midnight, so how do the police start investigation? First, they want to know who entered the building, which door was opened, what time did the incident happen, which security card was used. So the answer is what? They are digging into the log. Similarly, in the computer system, we have the logs, or you can call it like a digital diary that record the important events happening in the operating system, applications, and the network also, so logging is the process of recording the systems, applications, and network events so that they can be monitored, analyzed, and used for troubleshooting or security investigations. Because this is a very important part of security maintenance, that is logging. It provides a historical record of important system activities during a security breach or system failure. The logs will help the administrators to determine what happened, when it happened, and who was involved. So, the effective logging requires the organizations to capture the correct events, collect the logs from operating systems, networks, and the applications. So we need to plan the log collection and the storage during the system design, allocate the sufficient storage space, and use of automated log analysis to detect the suspicious activities efficiently. Proper logging greatly will improve the incident response, troubleshooting, and the overall system security. And then we have the data backup and archive mechanism. See, the data backup and archive mechanisms both are essential components in the security maintenance. Why? Because see, backup will create the regular copy of important data to support the recovery after the failures, then accidental deletions or cyber attacks. So this will help to maintain the data integrity. Whereas the archives will preserve the historical information for long-term legal, regulatory, and operational needs. So the organizations should define the backup and ar- archive policies during the system planning stage, and they can decide whether the data will be stored locally or remotely. So choosing between online and offline storage and the careful balance cost, which can ease of implementation, security, and the resilience when designing their backup strategy and all. See, the data backup and archive will work together to protect an organization's most valuable asset, that is its information. So while backup ensure quick recovery from failure and cyber attacks, whereas the archive will preserve the historical data for future legal and operational needs. So this will be creating a resilient foundation for business continuity and the long-term information management. And then we have the Linux or Unix security. See, this Linux and Unix security mainly depends heavily on the regular patch management and secure configuration, because the security patches should be applied promptly to address the known vulnerabilities and all. So the applications and various services, they are commonly configured using the text-based configuration files, so which are typically stored in the /etc directory or within the applications installation directory. So the individual users can customize their environments through the hidden dot files in their home directories. So finally, one of the most effective way to improve the Linux security is to disable or to remove the unnecessary services and the applications. So thereby reducing the attack surface and minimize the security risk, minimize the security risk. So in continuation to that, see, we need to understand the additional security mechanisms that are available in Linux and Unix systems, which includes the users, groups, and permissions, local and remote exploits, remote access controls, and logging and log rotation. See, these all the mechanisms which work together to protect the Linux system from both internal misuse and external cyber attacks also. So the Linux will control the access to every file and directory by using the permissions. So each file or the directory will have three categories of users: owner, group, others. So each category will receive the specific permissions, and three permission types will be there, like read, write, execute, like this. So the critical file permissions, which means the security guides recommended restricting access to important files and directories. So the local exploit will be there, a vulnerability that allow a user with local access to gain the elevated privileges and all. And then we have remote exploit, that means a vulnerability in a network service that can be exploited by an attacker over the network. So the Linux and Unix systems, they protect the resources using users, groups, and the permissions where read, write, and execute permissions are assigned separately to the owner group and others. So the security hardening will guide the recommended restricting access to the critical files and directories. So the organizations must also defend against the local exploits, which also the attackers with local access to gain the elevated privileges and all, and the remote exploits, so which have the target vulnerable network service. The host based firewalls and administrative utilities will help to control the remote access by allowing only the required service. So finally, logging and log rotation will ensure that the system events are recorded efficiently, while the administrator should always review and strengthen the default security setting rather than assuming they are sufficiently secure. They are sufficiently secure. So then we have another two concepts in addition to that, the chart jail. See, a chart jail is like a security mechanism which limit a process so it can access only a specific part of the Linux file system. So in simple way, the chart jail creates a virtual prison where an application can see only its own files and it cannot access the rest of the operating system. See, mainly, this concept improves the Linux security by restricting an application view of the file system to a specific directory, then preventing it from accessing the files outside that environment. So even though it adds the administrative complexity, it significantly limit the impact of a compromised application. So to further strengthen the Linux security, the administrators should follow the system hardening guides like the NSA security configuration guide and the regularly performing the security scanning and vulnerability testing. So this will be using the tools like Nessus to identify and correct the security weaknesses before they can be exploited. And then we have a concept of Windows security. See, Windows is the most widely used general purpose operating system, like in our personal laptops, in our home systems, businesses, and in various organizations and all. So, because of its popularity, it has also become one of the most attractive target for the cyber criminals. So, when you think about a large group of organization, they have many systems with Microsoft Windows operating system, and if they installed the operating system and just simply they left it, and it creates an access point for the cyber attackers and all. So the Microsoft Windows, as I said, which is one of the most widely used general purpose operating system, and it will be making it like a common target for the cyber attacks. So to address these risks, the organizations should implement the security countermeasures like the regular patch management, secure configuration, antivirus protection, the firewalls, and strong authentication. So the administrators can improve the Windows security by following trusted resources like the Microsoft security tools and checklist and the NSA security configuration guides. So these are all going to provide the recommended configurations and the hardening practices for the secure Windows deployment, for the secure Windows deployment. So here we have two important concepts. One is patch management, then user administration and access control. And also there is another concept called mandatory integrity control and all. See, the Windows security completely rely on the regular patch management using the Windows Update and also the Windows Server Update Service, WSUS. So while the third party application should also be kept up to date, so the access to the system owners will assign the permissions starting with um, access to the system resources is controlled through the discriminatory access control mechanism. Then where the resource owners are going to assign the permission. So starting with Windows Vista, they introduced another concept, mandatory integrity control, MIC, that will add another layer of protection by assigning the integrity levels to process and the objects. So by ensuring that lower integrity process cannot modify the higher integrity resources, so the MIC will help to implement the principles of the BIBA integrity model and strengthen the overall integrity of the Windows system and all. See, Windows security is strengthened through the continuous patch management, controlled resource permission, and mandatory integrity control. These are all working together to keep the system updated and also restrict the unauthorized access, and mainly to protect the high integrity resources from modification by low trusted process and all. So while the Windows administration and access controls are based on the principle of least privilege, the Windows assigns the system-wide privileges to the user accounts according to their responsibilities. So access to shared files is controlled using a combination of shared permissions and NTFS permissions. So providing detailed and flexible security, the user account control will ensure that the administrators normally operate as standard users and elevate the privileges only when necessary. So, reducing this risk of accidental or malicious system changes. Finally, the low privilege service accounts allow low running service like file, print, DNS service to operate with only the permission they require, limiting the impact of potential security compromises and all. And then the Windows application as well as the service configuration. Unlike Linux, here where I mean in Linux where most application use text-based configuration files, but in Windows it is stored much of its configuration information in a centralized database that is called Windows registry. Windows registry. So the Windows registry is a centralized database that is going to store the configuration of information for Windows applications, hardware devices, and even the user settings and all. See, the main purpose here is the Windows is going to store much of its operating system and application configuration information in the Windows registry. So it is like a centralized database that is organized into the key and values. So most applications automatically they save the user preferences to the registry, hiding the technical details from the users and administrators. So when advanced configuration is required, now the administrator can use the registry editor to modify the registry entries directly. So in enterprise environments, the registry setting can be stored in the central repository and automatically applied to the domain users during the login. So it will provide consistent configuration, easier administration, and also it will improve and also it will improve. See, the registry setting can be stored in a central repository, right? So, and also automatically applied to the domain users during the login, and it will provide the consistent configuration and the easier administration is possible, where it can improve the security across the large number of Windows systems and all. And in the same Windows, we have other security controls also. See, as I said earlier, the Windows registry is going to serve like a central configuration database for the operating system and applications. So this will enable consistent management of settings through the registry key and the values. So supporting the centralized administration and allowing the organizations to efficiently deploy the secure configuration across the large number of Windows systems and all. So the main thing here, the Windows security mechanism is strengthened by installing and configuring the additional security controls. So this will include the antivirus, anti-spyware, the personal firewall, and the malware detection software like this. So the modern Windows system already provide the basic firewall and malware protection capabilities, but the organizations often they deploy the additional security tools to achieve the stronger protection. When using multiple security products, the administrators must ensure that they are compatible so they work together effectively without reducing the performance or causing of system instability and all. So the effective Windows security depends on multiple compatible layers of protection like antivirus, anti-spyware, personal firewall, malware detection. So these are all going to work together with built-in Windows security features to defend the system against the modern cyber threats, while on other hand, it is also maintaining the stable and reliable operations and all. So in addition to this, we have other security controls in Windows operating system, because the Windows operating system provide built-in cryptographic function to protect the sensitive information through the encryption file system. So which encrypts selected files and folders, and the BitLocker which uses the AES to encrypt the entire storage drives. So in addition to the encryption, the organizations should regularly perform the security testing using security hardening will guide and vulnerability scanning tools to verify a secure configuration and identify the weaknesses. So the tools such as like Microsoft Baseline Security Analyzer, MBSA, will help the administrator to ensure that Windows system compile with Microsoft recommendation security practices or not, and also it will support the continuous improvement of the system security. And very important concept now we are going to see, that is virtualization. See, in today's generation, many organizations, many companies, many institutions, they rarely dedicate one physical system to one operating system. Instead, what they're doing, they are using the virtualization concept, and this virtualization concept allow multiple operating systems to run on a single physical computer, and it improve the resource utilization and reduce the cost. So a virtualization is a technology that create a virtual computer called virtual machine, and it will allow the software and operating system to run as if they had their own physical computer. See, this one is going to improve the hardware utilization, and mainly it will reduce the cost and simplify the system management. So there are two common approaches that are application virtualization, where the applications such as Java program run through the Java virtual machine on different operating systems, and the full virtualization. In this, where multiple guest operating system will execute independently, the virtual vision monitor will known as the hypervisor. This coordinates the accesses to the physical hardware resource and isolate the virtual machines. Even though the virtualization also introduce additional security concerns that require a very careful management. See, the virtualization enable multiple virtual machines to efficiently share a single physical computer through a hypervisor, that is a virtual machine monitor. So it improves the resource utilization and flexibility, while it requires the careful security management to protect both the virtualization platform and the guest operating system. So here, if you see, the hypervisor is going to be the central component of a virtualized environment. So it is going to sit between the physical hardware and the virtual machine, whereas it is going to act like a resource broker that will allow multiple virtual machines to safely share the hardware resources. That means each virtual machine run into its own guest operating system, which may be the same as or different from the host operating system. The hypervisor is going to perform several essential functions, including the execution management, so the device emulation, and access control, execution of privileged operations. So the virtual machine lifecycle management and administration of the virtualization platform will make it the foundation of secure and efficient of virtualization. And then we have a concept of full virtualization variants. So there are two variants. One is native virtualization, and another one is hosted virtualization. So in native virtualization, the hypervisor will run directly on the physical hardware. This will be provided better performance, fewer software layers, and stronger security. Whereas if you see in the hosted virtualization, the hypervisor operates on an application on top of the host operating system, which will be making it easier to install and suitable for personal computers and testing environments. But it will introduce additional security concerns because of the extra software layer. So choosing between these approaches mainly depends on the organization's performance and management requirements also. So in addition to this, see the native and hosted virtualization, both they enable multiple virtual machines to run on a single physical computer. But the native virtualization achieve higher performance and strong security because it is placing by hypervisor directly on the hardware, while the hosted virtualization offer great convenience for development and testing at the cost of additional software layers and increase the security considerations. See, traditionally, the network devices like switches and routers they had to be physically configured whenever a network changed, and this process was time consuming and inflexible. So, the software defined networking changes this approach by allowing the network to be managed through the software instead of manual hardware configuration. See here, SDNs, they allow the organizations to create flexible logical networks that span multiple servers and data centers while it is using the same underlying physical network. So this is achieved through the overlay networks which abstract layer 2, that is MAC, and layer 3, that is IP address, from the physical infrastructure. So this will be making the network design easier to modify and to extend. So the standards such as like DAO, distributed overlay virtual network, and the technologies like VXLAN, virtual extended local area network, these things will support the overlay networks so that the software defined networks also enable the organizations to deploy the virtual servers, virtual intrusion detection systems, and the virtual firewalls wherever they are required, improving the scalability, flexibility, and even the network security. And then we have the concept of containers. See, according to the system, the operating systems, the containers are also called container virtualization, or you can call it as application virtualization. So the containers are going to provide an isolated execution environment for the applications while it is sharing the host operating system kernel. Unlike the hypervisor based virtual machines, the containers do not emulate the physical servers or include the separate guest operating systems. So instead, a container engine will manage the containers with containerization sitting between the operating system and the applications. So this design results in lower resource overhead and the faster deployment. But because all the containers share the same kernel, it also introduces a greater security vulnerability that require a careful management, So there is a comparative look here. You can see that between native, hosted, and container. See, each of these technologies will allow multiple applications or operating systems to run the same physical computer, but they achieve all these things in different ways. Okay, because most of the modern enterprise environments they often use all the three technologies together. The production systems commonly rely on the native virtualization concept for strong isolation. The developer users hosted virtualization for testing across different operating systems, and cloud native applications are deployed as the containers to achieve the rapid scaling and efficient resource utilization. So, when we want to understand the strength and limitations of each approach, it helps the organizations to select the most appropriate virtualization technology for different workloads. So, then virtualized systems. See, in a virtualized system, the hypervisor efficiently share the available hardware resources among what, among multiple guest operating systems. So in partition, it is going to partition and schedule the CPU and memory by providing the storage either through the disk partition or virtual disk. So it is going to share the physical network resources by using the virtual network adapters, and typically it will assign the attached devices like USB drives and optical disk to one guest operating system at a time. So this resource management will enable multiple virtual machine to safely operate on a single physical server while it is maximizing the hardware utilization and maintaining the isolation. So then security concerns which include in this virtualization mechanism. See, in enterprises and even in cloud environments, the hypervisor is often considered most critical component of the virtualization platform. Why? Because see, it controls every virtual machine and it mainly manage all the shared hardware resources. So effective virtualization security depends on strong guest operating system isolation. So secure hypervisor management, protection of VM images and snapshots, and strict control of administrative access altogether will ensure that the benefits of virtualization are achieved without introducing the unnecessary security risk and all. So then the modern cloud platforms, they rely heavily on the virtual firewalls because most of the today's network communication happen inside the virtualized environment where the traditional physical firewalls cannot inspect the traffic. So by combining the resource isolation, secure image management, a bastion host based firewall, and hypervision firewalls, the organizations, they can achieve a defense in depth mechanism or approach that strengthen the security of virtualized infrastructure, and also it can maintain the flexibility and even the scalability and all. So within the with all this, it will provide a layered protection within the modern virtualized and cloud environments and all. So with this, we completed this module, and thank you all for joining today's session. Those who are not completed the discussion board activity 2, please complete it by end of today. I think is the due date, so please make sure that you complete it by today, those who are not submitted. And tomorrow, by early morning, you all will receive the assignment 2.
Doctor,
Yes, please.
I
Sorry.
I just joined at 8:20. I have internet issues.
Okay,
Can
okay,
you
no
check
problem.
if
Yeah,
I have?
yeah, I considered the attendance. All the 35 students here, they are all present today. Okay.
Thank you so much, Doctor.
Yeah, thank you. You're welcome. So students, please make sure that you all complete the discussion board activity without fail. And from tomorrow, the assignment 2 activity will be available for you all. Okay. By early morning. So the link is working now, and it will be published to you all soon. Okay. So the attendance for today's session is recorded. If you want to leave, yes, you are free to leave. Or else if you have any queries, please feel free to ask. Thank you.